Alright, hi guys, this is Precalculus 1C transforming functions because I am still bored. Alright, so first of all, basic transformations for the y coordinates. So first of all, what do I mean by transformation? So a transformation is basically if we want to change the graph of a function, right? If we want to keep the regular structure of the function but just like kind of shift it around or multiply some stuff, we just need to change the equation itself. And so we can do that a couple ways for the y values firstly. So if we, to multiply the y values by some value a, right, we use a times f of x. So if we have 1, 1 as a value, this would make it, and a was 2, this would make it 1, 2. To increase or decrease all the y values by some constant a, we use f of x is equal to f of x plus or minus a, right? And to reflect the graph across the x-axis, so to make all the y values negative, we use negative f of x. And so you might be thinking, well, this is just kind of a lot of random stuff. Like, how am I supposed to remember this? What does any of this mean? Why does this work? Well, if we think about it, an f of x is really just another way for writing y, right? It's just another word for y. And so if we multiply a times f of x, we're multiplying a times y. If we add a to f of x, we're adding a to y. If we make f of x negative, we're making y negative. So anything outside the function is going to affect the y values. And an important thing to note here is that transformations this way are literal. And what do I mean by that? I mean, if we multiply it by a, it's going to multiply the y values by a. If we add a, it's going to add a to the y values. And that might seem obvious at first, but it'll change when we get later and get more complicated. So just keep that in mind for now. And now an important thing to note is when we're graphing, because it's hard to move an entire line accurately, we're going to graph a couple specific points in the transform graph and then connect them. So let's get some examples. So let's say that f of x is equal to 3x minus 2. So first of all, what are some good points here? Let's take the y-intercept for 1. So if we have x is equal to 0, then y is going to be equal to negative 2. So that can be one of our points. And then we can also have, if x is equal to 1, then y is going to be equal to a 3 times 1 is going to be 3, minus 2 is going to be 1. So we're going to get this. These are our 2 points that we're going to use. So first of all, let's graph 2 times f of x. So in this case, we're just going to multiply all the y values by 2. So 0, negative 2 is going to become 0, negative 4. And 1, 1 is going to become 1, 2. And then let's just try to connect the dots. Not super accurately, but let's see if that's roughly right. Yeah, that looks good. All right. Now, negative f of x. So in this one, we're just going to make all the y values negative, or multiply them by negative 1, right? So 0, negative 2 is going to become 0, 2. And 1, 1 is going to become 1, negative 1. So that's going to be right here. And if we connect the points, yeah, that looks good. Again, it's not super accurate because my handwriting is a little off, but yeah, that looks good. All right, now let's say find f of x minus 1. So in this case, we're just going to subtract 1 from all the y values. So 0, negative 2 is going to become 0, negative 3. 1, 1 is going to become 1, 0. And we're going to connect those points. And is that roughly about where it is? Yeah, looks like it. Okay, now, basic transformations for the x coordinates. Now, these ones are a bit more complicated. So if we're changing the x coordinates, we're going to need to alter the inside of the function. So instead of saying a times f of x, right, or f of x plus a, we're going to do f of a times x, or f of x plus a. And some important things to note here is that it's going to work roughly the same, but the changes to the x are going to be the inverse. And what do I mean by that? Well, if we have f of a times x, it's going to divide all the x values by a. If we have f of x plus a, it's going to subtract all the x values by a. If we have f of x minus a, it's going to add all the x values. It's going to add a to all the x values. And that's just kind of something that you got to remember. There's no really good way to memorize that. It's just one of those weird things. Sorry. All right, let's do some practice. So let's say f of x is equal to x over 2 plus 1. So first of all, let's get our points. let's use the y-intercept again. So it's going to be 0, 1 because 0 over 2 is equal to 0 plus 1 is 1. And then let's take 2, comma, 2 over 2 is going to be 1 plus 1 is going to be 2. So let's take 2 as our other point. All right, now let's change these points. Find f of x plus 1. Well, because it's inverse, right, that's just going to subtract 1 from all the x values. So 0, 1 is going to become negative 1, 1. And 2, 2 is going to become 1, 2. And if we connect these points and then figure out, yeah, it looks roughly good. Again, a little bit off, but it's fine. F of 2x, well, if we remember, that's going to divide all the x values by 2, right? So because this is already 0, this isn't going to change. So it's going to just be 0, 1. But this one, 2, 2, is going to turn to 1, 2. And then if we connect those points, yeah, that looks good. Okay, now this one is a little bit more complicated. And that's only because if we have an interior shift, so if we have a like f of x plus 1, the x has to have a coefficient of 1 for that to be correct. And so we're just going to factor out 1/2 from this to get f of x plus 2. And now the interior shift is going to be correct. And so if we want, we can double check that. X times 1/2 is going to be x over 2. 2 times 1/2 is going to be 1. So this is the same function. But let's just take this in 2 parts. So first of all, we're just going to use red for the first change. So let's say we're going to be multiplying all of our x values by 2, right? Because it's 1/2. So 0, 1 again is not going to change because it's already 0. But 2, 2 is going to become 4, 2. And now we're going to subtract 2 from every single x value. So let's use a new color for that. Let's say blue, right? And so 0, 1 is going to become negative 2, 1. And 4, 2 is going to go back to 2, 2. And so this is going to be our final line. And let's see if that's right. Yeah, that looks a bit off, but it's fine. All right, so what if we have more complicated transformations? So they can be more complicated if there's multiple transformations on the same function, so kind of like what we saw with that last one, or if we have the same transformations but it's a more complicated function, right? So if it's like, let's say, square root of x, right, that's a more complicated function. X squared, that's a more complicated function. So the starting function itself can just be more complicated. And if that's the case, we're usually going to want to choose more like 3 or maybe even 4 points on the graph to transform and then connect them, just because the shapes of the graph itself can be a little weird. And if you have more than one transformation, just like we did back there, I would recommend doing one at a time just for simplicity's sake. So what's an example? Let's say we have f of x is equal to x, the square root of x, right? So first of all, let's get our points. So what's the square root of 0? Well, it's going to be 0, so that's an easy point. What's the square root of 1? Well, it's going to be 1 again, so that's an easy point. And then what's our next perfect square? Our next perfect square is going to be 4. And what's the square root of 4? It's 2. And so that's a decent amount of good easy points for us to use. Now let's say we have this absolute beast of a function. So let's just take this one step at a time. So if we have 2 times f of x, right, we're going to multiply all the y values by 2. So that isn't going to change 0, 0, but that is going to make 1, 1, 2, 1, and that is going to make 4, 2, 4, 4. So we have that. Now let's switch over to a yellow, and we can subtract 1 from all the y values for our next step. And you don't really have to do these in any specific order. I'm just doing these in this order because I like it. But we have, so 0, 0 becomes 0, negative 1. 1, 2 becomes 1, 1 again. And 4, 4 is going to become 4, 3. Now, and we notice here before we do any interior ones, we do not have a coefficient of 1. So we're going to make 3x plus 6. I don't like that color. We're going to make 3 times 3x plus 6. We're going to factor out a 3 from that and make it 3 times x plus 2. Now we can work with that. So I'm going to use a green, and we can start with the dividing. So we're going to divide all the x values by 3, and we're going to get some weird points, but it's whatever. So this is going to stay the same because it's 0. This one it's 1, so it's going to be 1/3. And then this one is 4, so it's going to be 4/3, which is about here. And then let's subtract everything by 2. Right, so this is just going to become, let's use blue for this one. This one is just going to become -2, 1. This one is going to be something like this. And this one is going to be something like this. Yeah. And now this isn't super accurate because we're doing a bunch of different functions and it's not going to be super good, but let's just check. Yeah, if it looks like we got the relative shape down. So when you're doing this on paper, you can do a better job than I can because I'm just doing this on the computer screen. But if you get the rough shape, that's okay. But that's going to be all for right now. So thank you. Bye. Leave me alone.